Alright, so let's look at working another optimization problem. I have a bunch of them I'm doing, so check them all out. Uh, so here we want to know what is the minimum vertical distance between the parabolas y equals x squared plus 1 and y equals x minus x squared. Alright, so first thing we want to do is just make a sketch of this. So if I sketch this, okay, so if I sketch x squared plus 1, I know that's a parabola that opens up with a vertex at 0, 1. So we'll just say that's right there. We'll exaggerate that 1 unit so we can get some, get some distance between our graphs so we can see what's going on and everything's not so cluttered up. Now let's look at this one. Well, this one is a parabola that opens downward. I know it's going to go through 0, 0 because if I plug 0 in, I get y equals 0. So we need to find the vertex. So if you remember, the vertex of a quadratic is minus b over 2a and then f of minus b over 2a. This is the x coordinate, this is the y coordinate. So let's go ahead and find the vertex. So minus b over 2a, well, b is 1, that's the number in front of x, so that's minus 1 over 2 times a, so 2 times a is the number in front of x squared, that's negative 1, so that's 1 half. So there's the x coordinate of the vertex. And now I need the y coordinate. So I just take the 1 half and plug it in. So I get y equals 1 half minus 1 half squared is 1 half minus 1 fourth, which equals 1 fourth. And so there's the vertex, 1 half, 1 fourth. We'll just say that's about right in there. And then if I draw my parabola, it's going to look something like that. Okay. All right, so let's go ahead and find the minimum distance between these two. All right, so if I'm just going to draw a line in here, right here, and I'll call that D. That's the distance between the 2 points. Okay, now where that point is, I don't know. It's probably somewhere in here, so we'll just sketch it in there somewhere. All right, so if you remember, the distance between 2 points, x1, y1, and x2, y2, is d, the distance, is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we need some point coordinates here. All right, so the coordinates of this point we'll call x, y. Now for this graph, what's y? Well, y is x squared plus 1. Okay. And then for this one, we'll go over x units. So that x coordinate will be x, and the y coordinate will be x minus x squared. See, that's y, x minus x squared. So I need the distance between this point and this point. And it really doesn't matter which one you call x1, y1, and x2, y2. But what we'll do, we'll just call this one, let's see here, we'll just call this x2, y2, and we'll call this one x1, y1. Alright, so the distance is equal to the square root x2 minus x1, so that's x minus x squared, plus y2, which is x squared plus 1 minus y1, which is x minus x squared, and don't forget to put that in parentheses, and then all that's squared. So the distance is equal to the square root. Now this just goes to 0, And so I'm left with x squared plus 1, and then distribute the negative, minus x plus x squared. And all of that is squared. And so the distance is equal to the square root of, let's see, 2x squared minus x plus 1, all of that squared. So the distance, well, if I take the square root of this, I'm just left with 2x squared minus x plus 1. So that's the distance between those 2 points there. So we need to find the derivative. So the derivative is equal to 4x minus 1. Set this equal to 0. 4x minus 1 equals 0. So x is equal to 1/4. And we can come over here and we can show that this is a minimum. This is my critical value, or my critical number. So I can choose x equals 0 and x equal 1. So if I plug the 0 into the derivative, that's 0 minus 1, that's negative. So that's decreasing. I plug the 1 in, that's 4 minus 1 is positive 3. That's increasing, and you can see there I have a minimum value. All right. So the value x equal 1/4 is going to give me my minimum distance. But remember what they're asking, they want to know what is the minimum vertical distance. So to find that, I'm going to take the 1/4 and plug it back into my distance. So the minimum distance is 2 times 1/4 squared minus 1/4 plus 1, which that is equal to 1/8 minus 1/4 plus 1, which equals 7/8. And that's the minimum distance between those 2 parabolas. All right, so I hope the video helped. Check out my other ones. Give me a like, share, and subscribe, and thanks for watching.